Hey everyone, in this video we're going to discuss what is AWS Aurora. As you can see here, this is Amazon Aurora. When do we really use AWS Aurora? Is it Amazon Aurora or AWS Aurora? Is it Amazon Aurora or AWS Aurora? The official name is Amazon Aurora, as it is a service provided by Amazon Web Services. However, the term Amazon Aurora and AWS Aurora are often used interchangeably in casual conversation because AWS is Amazon's cloud computing division. For precise communication or documentation, it's best to use Amazon Aurora. Okay, so yeah, we got it. So what is Amazon Aurora? Aurora or Aurora? It is an unparalleled high performance and ability at global scale with full MySQL and PostgreSQL compatibility. Okay, so Amazon Aurora is a managed relational database service offered by AWS. It is part of the Amazon Relational Database Service family and is designed to provide the performance and ability of high-end commercial databases while being more cost-effective. Aurora is compatible with MySQL and PostgreSQL, meaning it can be used or you can use it as a dropped-in replacement for those databases with minimal changes to your applications. Key features of Amazon Aurora: high performance. Aurora offers up to 5 times the performance of standard MySQL and twice that of Postgre. Okay, so we just have a question in mind right now. We don't want to lose it, so we're going to put compare to SQL Server, Oracle, and what else? Okay, so I think that's it for now. Compare Aurora 2. Okay. Okay, so number 2, scalability. Supports automatic scaling for read and write operations. High availability. Replicates 6 copies of your data across 3 availability zones. Security. Includes encryption at rest and in transit, with integration into AWS security services like IAM and KMS. Managed service. Automated backups, snapshots, and updates reduce operational overhead. Pros of Amazon Aurora: performance and scalability. Higher throughput compared to standard MySQL and PostgreSQL. Supports read replicas up to 15 for better read performance. High availability. Multi-AZ deployment ensures minimal downtime. Automated failover mechanism. Cost efficiency. Delivers commercial database-like performance at an open source database cost. Integration. Works seamlessly with other AWS services like Lambda, Redshift, and S3. Ease of migration. MySQL and PostgreSQL compatibility make it easy to migrate from existing setups. Cons of Amazon Aurora. For cost, more expensive than standard RDS, MySQL, and PostgreSQL. Vendor locked in, fully managed by AWS, making it hard to migrate away from the AWS ecosystem. Complexity might be overkill for small scale applications that don't need advanced features or high performance. Limited ecosystem. While compatibility with MySQL and PostgreSQL, not all extensions or plugins are supported. Data ingress costs. High costs for transferring data out of AWS. So comparison to other RDS offerings. So Amazon Aurora is 5 times faster than MySQL and 2 times faster than Postgre. For RDS performance standard, RDS SQL Server high, depends on edition. RDS Oracle high, depends on edition. Cost moderate to high, lower, higher, higher. Also, MySQL Server, SQL Server and Oracle is higher than Aurora. Compatibility of Aurora is MySQL and PostgreSQL. SQL Server is only for SQL Server, and Oracle is only for Oracle. Scalability, automatic, and for SQL Server, limited, and manual scaling, also limited, and manual scaling for Oracle, and also for RDS. So it's automatic for Aurora for automatic scaling. Availability, multi-AZ, automated failover. RDS is multi-AZ optional, multi-AZ optional for the 3 RDS, MySQL, Postgre, SQL Server, and Oracle. So I think it's 4. Yeah, and then for use case, high performance cloud native apps, general purpose database for MySQL, PostgreSQL. SQL Server is enterprise.NET apps. Oracle is enterprise apps with Oracle. Okay. So who is Amazon Aurora for? For enterprises needing high performance, high available databases at a relative lower cost compared to commercial solutions. SaaS providers hosting multi-tenant applications that demand scalability and performance. Startups looking for managed high-performance databases without the operational burden. Existing AWS users leveraging AWS ecosystem for applications that require database compatibility with MySQL and PostgreSQL. When to choose other RDS options. You will choose RDS, MySQL, PostgreSQL for cost-sensitive applications that don't need Aurora's performance or scalability. Choose RDS SQL Server or Oracle for legacy applications or enterprise environments requiring those specific database engines. NoSQL, for example DynamoDB, for applications requiring non-relational databases with high scalability and flexibility. Okay, so I believe that's it. Are we still going to compare Aurora, SQL, and okay, so we have the comparison to it already, but let's try. Okay, so for performance and scalability, performance, yeah, we read it on the previous table above. For scalability, automatic scaling for Amazon Aurora, for SQL Server and Oracle, those are manual scaling for most editions. For Oracle, they have vertical scaling more common. For replication, up to 15 low latency read replicas. For SQL Server, basic replication with manual setup, advanced replication features like data guard for Oracle. For availability and reliability, multi-AZ with 6-way data replication. For SQL Server, multi-AZ option with failover support. Oracle multi-AZ and Oracle RAC for HA. I'm not sure what that is. So for the failover, automatic failover in less than 30 seconds. Failover time depends on configuration for SQL Server. Cost, pay as you go based on usage. License required. Bring your own license or manage cost. High license cost for Oracle. Total cost lower compared to SQL Server and Oracle for the Aurora, higher for enterprise features, higher due to licensing and features. Compatibility and ecosystem, integrated with AWS services, tight integration with .NET and Windows for SQL Server. For Oracle, strong integration with Oracle tools. Amazon Aurora, MySQL and Postgre compatibility, SQL Server compatible with .NET and MySQL Microsoft tools, works with Oracle specific tech. Use cases, high performance cloud native apps. For SQL Server, Oracle enterprise apps relying on .NET stack. Aurora is more on web and mobile apps. Okay, transactional workload, scalable OLTP workloads, OLTP but more traditional deployment. Analytics, for Aurora Analytics and SQL Server works well with data lakes on AWS, and for Oracle suited for data warehousing, SSAS. Strengths are Amazon Aurora, excellent for cloud native applications requiring scalability and high performance. Lower cost compared to SQL Server or Oracle, automatic scaling and failover capabilities. SQL Server best suited for enterprises using Microsoft technologies, .NET, and Windows. Robust business intelligence tools like SSAS, SSRS, and SSIS. For Oracle, superior for high-demand enterprise systems needing advanced features like RAC and data guard. Strong analytics and data warehousing capabilities. So weaknesses, Amazon Aurora lacks some advanced features of enterprise databases like RAC, limited to MySQL and Postgre capability. SQL Server, costly for enterprise editions, limited scalability compared to Aurora in a cloud-native environment. Oracle, it's expensive and complex licensing. Overhead for managing advanced features like RAC. Who should use what? Amazon Aurora for startups, cloud-first companies, and businesses looking for high-performance relational databases at a lower cost, ideal for mobile web or mobile apps and scalable OLTP workloads. For SQL Server, it's for enterprises deeply integrated with Microsoft ecosystems or requiring advanced BI tools, suitable for legacy .NET applications. Oracle, enterprises needing advanced analytics, RAC, or data guard, critical systems requiring high availability and scalability in an enterprise-grade environment. What is Oracle RAC? Hold on, I'm about to sneeze. Did we pause it? Okay, so key features of what is Oracle RAC or Real Application Clusters? Is an advanced feature of Oracle database that enables multiple servers nodes to run a single database instance. Okay. This setup provides high availability, scalability, and fault tolerance by allowing multiple nodes to work together as a single system. If one node fails, the other continues to operate, ensuring the database remains accessible. Key features of Oracle RAC: high availability. RAC ensures continuous database availability by eliminating a single point of failure. If one node fails, others take over seamlessly. Scalability supports horizontal scaling by adding more nodes to the cluster. Allows applications to handle increased workloads without downtime. Load balancing distributes database workloads across all nodes in the cluster for operational performance. Transparent application failover automatically redirects client connections to other node in case of a node failure. Shared disk architecture. All nodes access the same shared storage, ensuring data consistency and integrity. Cluster management includes tools like Oracle Clusterware for managing and monitoring the cluster environment. How Oracle RAC works. RAC operates in a shared disk model where all nodes across the same physical storage. Huh? Where all nodes access the same physical storage. Each node runs its own Oracle database instance but shares the database data and metadata. That's cool. Oracle Clusterware, or third-party clustering software, manages nodes communication and failover. Benefits of Oracle RAC. Fault tolerance ensures that the database remains operational even if a node or I have a question in mind. RAC is same with read replica. Okay, so ensures no, it's not the same. Ensures the database remains operational even if the node or server fails. Scalable architecture can add or remove nodes dynamically based on workload requirements. Improve performance, distributes queries and transactions across nodes for better resource utilization. Simplified maintenance. Maintenance on one node doesn't affect the availability of the database. Alternative to Oracle. Challenges of Oracle RAC. Cost requires additional licensing and infrastructure, making it expensive. Complexity. Setting up and managing RAC requires expertise in clustering and Oracle databases. Shared storage dependency requires a reliable, high-performance shared storage systems. Network latency, communication between nodes can become a bottleneck in poorly configured environments. Use cases for Oracle RAC: mission-critical applications, financial systems, healthcare databases, and other systems requiring near zero downtime. Scalable applications that experience fluctuating workloads and need dynamic scaling. Disaster recovery ensures high availability and geographically distributed environments. So here, alternatives to Oracle RAC. Amazon Aurora provides high availability and automatic failover in a cloud-native setup without requiring shared storage. PostgreSQL with Patroni, open source alternative offering high availability and replication. SQL Server always on, Microsoft's high availability and disaster recovery solutions. Okay, that's it. Okay, thanks. Bye.